welcome to the Using Docker track. I'm excited to have Elton Stoneman here. He's a developer advocate with Docker. And previous to that, spent 15 years delivering software as a .NET developer as well as a publisher. So a lot of you might have read some of his books. And he's going to cover 5 patterns for success for application transformation. So turn it over to Elton. Thanks.
Thanks very much. Thank you. Well, that's kind. I haven't done anything yet. So my name's Elton. I work for Docker. Prior to working for Docker, I spent 15 years as a .NET architect, working for enterprises, big solutions. Saw the light, joined Docker. Brief introduction. So even though I work for Docker, if I want to speak at DockerCon, I have to submit a proposal, just like everybody else, and it gets debated, and I might get through or I might get not. The feedback for this session, which was that the content, they liked the content, but they thought the title was boring, which I can get that. 5 patterns, I can't even remember it. So the feedback was maybe you can have a jazzier title. So I was going to rename it Power Your Blockchain with a Serverless Platform on Kubernetes. And then I was going to do the same content that I'm about to do. So I just left it as it was. OK. So the aim of this session is to deal with this very real problem that people are facing in the industry, which is called Netflix envy. So all the people in this room who are practitioners, you want to get better at what you do, you want to deliver better software, do a better job for your company, and you spend all your time feeding into the stream. So you come to great conferences like DockerCon, you read the Twitter stream, you read the blogs, and you're seeing all this fantastic technology, open source technology, coming from companies like Netflix, who are doing 2,000 deployments a day. And they're running all this great DevOps stuff, and they're running all these great microservices. And then you go to your day job, and you sit there, and you're managing or developing a 15-year-old application, and you're thinking, well, what's the point of learning all this stuff? OK, so this is where containers come in. So when you're running your applications in containers, and it doesn't matter what your orchestrator is, whether it's Swarm or Kube or anything else, to the container platform, all the apps look the same. They've all got the same shape. And you can take advantage of that to make your old apps behave in the same way as new apps. So when you spin up a container, what the platform does is it kind of creates this hole for the container to fit into. And all these little bits here, these puzzle pieces here, you'll see some of the lines don't actually line up correctly. It's very difficult to get these things to line up when you're drawing these puzzle pieces. When these little pieces are integration points with the platform. And if you're running a modern application, like a Node.js application, they're built to run in this sort of style. And they integrate really nicely with Docker, with the container platform, without you having to do anything much. They fill out and they integrate with all the integration points. Now, Docker's really forgiving. It doesn't make you integrate with those integration points. And you can take your old legacy applications, don't say legacy, your traditional applications, I need to, like a swear box, and you can put them in containers, but they look, that's your back one. Oh, I missed a slide. They don't fill out they don't fill out to all the edges. This slide should be, this is debugging a presentation. That's pretty cool, hey? They don't fill out all the edges. So they run inside the container, but they don't integrate with the platform. So you can't manage them and use them in the same way that you do a brand new application. So what are those points? Well, I'm going to cover each of them in the session today. This is what these 5 patterns are about. They're these 5 integration points with the platform. So things like getting logs out from your container. Yeah, I know, it's boring. It's the most boring thing. But without that, if something goes wrong, you don't know what's happening. It's getting config into your container so that you have the same image in every environment. Your release process is deploying a container from the same image that you've tested in all your other environments. But you push the config in, so your binaries are the same. It's checking from the platform to see if your dependencies are up and running, to make sure that what your application needs to function is actually there. And the obverse of that is getting health information from your application back to the platform, so it knows if it's behaving correctly. And if it's not, it can take corrective action. And the last thing is metrics. So getting information about what your app is doing so that you can suck it all into a dashboard. Because when you were used to having your monolithic application that ran on 2 or 3 servers, it's OK to connect to see what's going on. But when you've got that same application running in dozens of containers across 100 servers, you can't connect to these things. You need to get the metrics out. OK, so that's what this session's about. It's about filling in the blanks, taking your old applications and making them behave in the same way as new applications. With a couple of important things, important to me. I should say there's some opinion stuff in this session, without changing code. So some of us here are going to be developers, and some are going to be ops, and some of that mixture. It doesn't really matter you're going to have some applications that you're not actively working on. You maybe want to put them in a container and run them in the cloud. And you want to take advantage of all the fantastic stuff that we saw this morning with federated Kubernetes clusters and all that sort of stuff. To get there, first of all, you have to be running in a container. You might not be changing code, and it's important to be able to make your apps good Docker citizens without having to rewrite the code. The second thing is not taking a dependency on a particular technology. So don't get yourself in the position that your app only runs on one particular orchestrator. So there are lots of different ways of doing all this stuff, and some of the patterns I'll show you, there are alternatives. But an alternative might mean you can only run in Kubernetes, which means later on down the line, you're stuck if you want to move to a different orchestrator. And the last one, don't break the dev workflow. So don't focus so much on production that developers can't just run a container. You should be able to just run a container from the production release and have that code running locally without all the bells and whistles, but you shouldn't have to understand how to configure it properly. And we'll see how to do all that stuff. OK, so number one, logging. So all the platforms that we're looking at, and today I'm going to be showing you a Java application that I wrote with, so I spun up a virtual machine to write my demo apps, and I installed NetBeans 6, which was released in 2008, and I installed Visual Studio 2008, and I made genuine 10-year-old applications so that I can show you this stuff is real for legacy apps. Those platforms and all those older platforms have some notion of logging already. And your app probably does some sort of logging, but it's not connecting into Docker. So the pattern you need to do for this is you've already got some sort of log sync inside your application, whether it's writing to a file or the Windows event log or syslog. You need to know where that is, and you're going to package a utility alongside your container, your application inside your container, and you're going to run that utility in the foreground. And that utility is going to read from the logs that your app is currently writing and relay them back out to Docker. So what you end up with with this pattern is two things in your container. Your application that you care about, that's going to run in the background now. And your log relay is running in the foreground, and that's pulling stuff out and pushing it into Docker. There's downsides to that, but we'll cover that in a later pattern. OK, lots of demos. So let's show you what this looks. So this first demo is going to be with .NET. So I have my cluster here with a couple of nodes. And I've already deployed one version of my .NET application. This is my application. This is open source. This very permissive license. You can use this application in your own company without any problems at all. This is all it does. It reads some configuration files, and it's got two buttons, one to write some log entries and one to execute a SQL query. So this is just a really simple demo application to show you how all these patterns fit together. So I've got here information about the logging that's already configured in my app. So I'm using Log4Net, which is a popular .NET logging framework, along the same lines as Log4j. And I've already configured inside my application that I'm going to be writing to this log file here. And when I click this button, Write Logs, it's just going to write some logs. That's all it does. Writes to the configured log sync. Now, if I go and look at this container, and if I go to my service, it's a .NET container. I'll go and check it out. I can see it's been up for about an hour, so I started it when I was prepping. And if I go and look at the logs, it says waiting for logs, and it's just going to stay that forever, because there are no logs coming out of my application. So Windows applications are a particular problem in this space, because typically they run in the background anyway. So my web application is sat running in a Windows service inside my container, running in IIS, which is the web platform. And that's running in the background, and Docker is not watching that process to get any log entries out. So in order to make this work, what you do, and all this stuff, I'm going to switch to my .NET here. So my version 0 Docker file to produce the application that you saw just now doesn't do anything clever. All it does is it takes a zip file with the application already compiled. So imagine I've got a CI process that spits out some sort of deployment artifact. It deploys it inside my Docker image, and then it runs some PowerShell to set up the application. That's all version 0 does. Version 1 follows the logging pattern, and it deploys some extra stuff in here. So what it deploys is a startup script. It uses a volume. So it creates a volume where my logs are going to be stored. And it copies in this startup script, and it overrides the base entry point to provide its own entry point, which is this script. It's a really simple script. All it does is it starts that background service. It starts the IIS service, which is going to actually run my application. And then it makes one call to the local host, which warms everything up. So this is getting past the cold start issue, so everything's warmed up for me now. And that also writes an initial log. So at this point, when this is executed, I've got a log file. I know exactly where it is. So this is where the pattern kicks in, and this is the process that Docker's going to run. This is the foreground process which will run for the life of my container. All it's doing is tailing that log file and relaying it back out to Docker. It's very simple, but it means I can now get the logs that are already running in my application, and I can bring them into Docker without having to change any code. So I'm going to deploy a new version of my app for this. Let's switch back to here, check I'm in the right place. And so demo number 1. So Docker stack deploy, it's just that I'm deploying it all to Swarm, although I could be using Kubernetes from the Java side. And it's just going to update the new version of my service. The Swarm file is, the compose manifest is, again, really simple. And all I've got in here for version 1 is my web application, and I'm publishing the ports. These little bits and pieces here are to do with Windows, and it's just a very simple definition. I haven't had to change how that's specified in the manifest. So if I go back to my services, and my web app, and I check my containers. The old one's finished because I've just done a new deployment, and my new one's been up for 17 seconds. And if I check the logs, these are the logs that get written as part of my startup script to say that everything's being configured correctly. So if I now go back to my page and reload it, I should see a different server name. This slow mode, that comes in later on. That's important later on. So this server name is just the container name. I haven't changed the configuration here. The logs are still being written to the same sink inside the container, but now when I click on my Write Logs button, the relay is picking those up from the file and pushing them back out so Docker can read them. So now if I refresh my log entries, oh, it's exciting. Oh, no, I didn't do the thing. I didn't do the thing, but there are a bowl of them here, and I forgot to do it. Let's just double check that this is the right container. OK, I'm going to do this instead. I'm going to do Docker service list, and I'm going to go and do service. The number of times I write Docker in an average day is about 1,000, and I still get it wrong every time. OK, so there are the logs. So it just hasn't come through in the UI yet. So these are the logs that are originally being written by my traditional application. They're writing to a log file, and I'm just scooping them out. It's nice and simple. But it's a really good way to get started with getting your app into the world of containers. And the reason why it's important is because Docker has this plugin system for logs. So you can configure your Docker cluster so that any logs that get written from containers go straight to Splunk or go straight to Elasticsearch or whatever you want, or get surfaced in the UI in Docker EE. So as long as you can get your logs out of the container, then out from your application into the container, then Docker can manage all that stuff. So as the first example, it's nice and simple. There is a problem, though, which is that when Docker runs a container, it monitors the foreground process to see if your app is still running correctly. And the foreground process right now is just this tail that's just going to watch my log file. So Docker now doesn't know if my application is healthy, but we'll come to that later. OK, number 2, config. So I mentioned at the beginning, it's really important that when you start thinking about how things work with containers, your Docker image is going to be bundled with some default configuration. So you're going to package your application in your image so that it runs correctly in dev. So we'll have a whole bunch of dev configuration already set up. That's important so that developers can just do, or in a test environment, you can just do Docker container run, and the thing starts, and it works. And you don't have to know all the tweaks that you have to apply in your compose file to make it work correctly, because it's bundled with some default configuration. But you need to be able to take that image that's been produced by your CI server and run in your test environment and run in your UAT environment and go to production, and it's the same image every time. You need to be able to inject the config from whichever environment you're running in. So this is, again, it's a fairly simple pattern. The idea is you've got your default configuration in the image, but you know where your configuration files live. So you know the paths to your configuration files inside the application image. And then you can set up your Docker file so that it injects configuration that comes from the platform. And so that could be a Docker config object, or it could be a Kubernetes config map. In both cases, they get surfaced inside the container as a file. So all this pattern is going to do is say, if I'm set up to read config from the platform, then I'm going to overwrite the config in the application. I'm going to overwrite the default config that's in the image. And I'm going to use the config that gets provided by the platform. So the platform can inject this stuff. OK, demo. I'm switching to Java for this demo to show you that it works both ways. So here, let's get rid of this. So here's my Java app, which is very familiar because it's exactly the same, but it's written in JSP, and it's again it's exactly the same principle. This is version 1, where like it just you've lost me. Let's do this instead then. Well, that's not right. How long ago did that go? Because you can tell just now, okay. Because sometimes this is like, well, that's been going for half an hour. Okay. Okay, so I'm going to do something dangerous now and just yank the cable and see if it comes back when I plug it back in again. If not, then I know what I'm going to say, so I can just talk about it for the next half hour. Oh, so it doesn't. I don't know why it's doing the. It's sharing some sort of extra screen.
Yeah. Go to no, you don't want to show mirror. Right. It wants to be on.
So we've got a break after this session, so if it takes a few minutes to sort this out, that's fine. What was I talking about? Configuration, yeah. So I could read you out the Docker file line by line, but it's going to be difficult to hold that in your head. I could show you my spare laptop. Can you see that at the back? No? OK. All right. So I think it's OK. We'll get this sorted out.
If you want to plug that in, you can too.
Yeah, see, it's all running on this one, so I don't. Let's.
Back.
Yeah, see, now you're on that other screen.
Yeah,
OK. All right.
Go to scale.
Nearly. Fire!
Now.
No.
Now go to the other one. Now hit mirror on.
What's the arrangement here?
Put the mirror on again.
There we go. Look at that. I hope we clap as much at the end. OK, so thank you very much. This is Mo. Say thank you to Mo, people. OK, so what was I doing? Can anyone remember? Something to do with configuration. Yes, I remember now. OK, so this is my Java application. It looks exactly the same, and it's got the same two bits of functionality. I can write to logs. I can call a SQL database. This is MySQL in this case. OK, so right now, the configuration, you can see it's doing the same sort of thing. It's using the standard Java logging framework, the SE logging framework. And it's also reading out the configuration that's bundled inside the image. So inside the image, there's some default stuff that says I'm going to log to debug level. I'm going to write to this target, which is on the C drive. And I'm going to write 5 logs every time you click the button. OK, so that's fine for dev, but in production, obviously, I want to be able to configure that. I want to be able to see more stuff. If I click on write logs here, although it says I wrote 5 log entries, if I go and look, oh, wow. If I go and look at my logs now, so I'll switch to this container. There's only one each of these containers because this isn't really a production app. I know, I claim it's going to be production-y. So what we've got here is there's a whole bunch of stuff which comes from the base image. So this is running in Tomcat. When you run a Tomcat container, it spits out all these logs for you anyway. But these are not my application logs because they're still bundled inside the log file somewhere. OK, so what I'm going to do is deploy a new version of this app that has that's reading the configuration from my cluster. So if I do a Docker. This is also too small, isn't it? If I do a docker config ls -- filter. So I've already deployed my configs. I've got a bunch of things from my Java app. So I've got a logging file and a web config file. So the two things that the application is reading in order to decide how to operate. So if I go and inspect this one here, which is my logging config, I do a docker config inspect, and I'll do that pretty. Then this is the configuration that's stored inside the cluster. So again, you could do this with Kubernetes with a config map. In Docker, it's called a config object. So what I want to do is deploy the application so that gets provided from the cluster. So the version that I'm going to deploy now, my Docker stack file, I've got this pattern involved, and it's done by these config elements. So there's two parts to this. So one, I need to read the configs that are coming from the cluster, that are coming from my container platform. So what I'm saying is there's a config object called java.log-logging, and I want you to surface that inside the container at the root directory, at the root/logging.properties. And I can also configure the read access for it, the mode. And those are config objects that are defined that are already existing in the cluster. Okay, so that's going to get them and surface them inside my application, but they're just going to be in a different place from where the application expects to find them. So the startup for the application needs to override what's currently packaged, the defaults in the image, with what the container platform is providing. So that's done in the Docker file. So in my Docker file for version 2, I have a couple of environment variables that I'm setting, and that's the path to the config file that's being provided by the platform. So inside the swarm configuration, I'm saying take your config object from the platform and surface it inside my container at /logging.properties. And what I'm doing here is I've got a startup script, a little shell script, that is going to create a symbolic link from the file that Swarm has provided to where the application is actually going to read it from. So it's going to ignore the bundled configuration, and it's going to use what's been provided by the container platform. Okay, so for each of these, it's going to say, if a value has been provided for the environment variable of where I should get the config file from, and if that config file exists, then I'm going to create a symbolic link. So I'm going to overwrite what's currently there, effectively. And I do that for my logging, and I do it for my web XML. And then the rest of this stuff is just what comes from the base image that I'm just bringing into my startup script. So I'm overriding the startup script. I'm doing this work before my application starts. So when it runs and it reads logging.properties in the expected location, it's actually coming from the cluster. OK? So I've said all that, but I haven't actually deployed it yet, have I? So we're not going to, nothing's going to be different until I do that. Come back here. OK, so deploy Docker Stack version 2. And again, all that's changed here really is the version of the image. So I've already built all these images. Version 2 has the logic to be able to suck config out from an external location and overwrite whatever's in the application. It's exactly the same principle for the .NET version, by the way. I should have done a show of hands of who was Windows and who was Linux, but I don't really want to, because if nobody puts their hands up for Windows, then it feels silly that I'm doing the demo. So I'm going to leave it as a surprise. So with the .NET version, the principle is exactly the same. Version 2 here. So I've got environment variables to capture where I should be getting my config files from. I've got a startup script, it's a little bit easier to read in PowerShell, that says if you provide me with a source path and that path exists, that's where the source of the config should be coming from, that's what the swarm is going to populate, then I'm going to remove what's currently there, and I'm going to create a new symbolic link. So the app doesn't need to know that the config is in a different place. The app is still looking where it expects to look, but it's coming from the platform. OK, so now this should be running. Let's clear that down, look at my services. So it's been up for about a minute. Have a look at the logs. Server started up, excellent. So I'll reload this, zoom in a little bit. OK. So, I mean, there's not a very exciting reveal here. You can see that the level now has changed, and it's using the console handler. So that's the configuration that's stored in the swarm. It's been provided into the container, and then the startup script has replaced what's currently there. And the log count is changed to 3. I don't know if I can zoom much more here. So when I click on Write Logs, wrote 3 log entries. And I'll go back here, and there are my 3 log entries. So these are the 3 things that are coming from my application. All it does is write log 1, log 2, log 3. But now I can see them inside my container. So this is a combination of the fact that the logging is already working, and now I can use my configuration to set up the logs and any other application configuration that I want to. OK. Let's switch back here, and then let's see if everything comes back again afterwards. That'll be exciting, won't it? OK, number 3, dependencies. So we've done logging, we've done configuration. These are in rough order of desirability. So you can't do anything without your logs. So if something goes wrong, you can't find out what's happening. So your logs are number 1. Configuration is number 2, because you can't have the situation where you've got different images for each environment. That kind of defies the whole point of having a portable Docker image. Number 3 is dependencies. So these applications here, they both make use of a database. I'm not running a database at the moment. So the application doesn't know that. Traditional applications tend to be designed with the expectation that everything will be there. So if I use a database, then I expect it to be there. And I'll write my database access code without any retry logic or any exception handling, because if the database isn't there, the app is not going to work. And that was OK when the database was an actual thing that had lights on it, and you could see it was all working. But now, it's the same issue with the cloud, actually. If you're running a cloud database, there are going to be intermittent issues. And same if you're running your database in a container. There might be intermittent connectivity issues. And database is just one example. APIs are another great example because they might not be available for a few seconds. You want your app to be able to say, when I start up, I need to check everything that I need is available. And if it isn't, then I'm not going to start. Because otherwise, it looks like I'm working correctly, but I'm actually not. So the pattern here is we're going to have a utility that we bundle with the application. And it's going to run before startup. And it's going to check all the dependencies that the application needs. Now, you could do this with a script, but it would probably get horribly complicated, and it would limit your ability to do interesting stuff. So the examples I've got here, and remember, this is all on GitHub. I'm not going to show you the link until right at the end, so you have to stay. This is all on GitHub. The examples I use, I write the utilities in the same platform that the application runs in, for a couple of good reasons. The first one is it lets you use whatever config is set up. So if I've got a dependency checker application that's written in .NET, it can use the same config file that my web application is using. And that's already been set up to read all that stuff from the platform. So that's one really good thing. The second really good thing is I don't need to take a dependency on some third-party tool. So I don't need to do like a add curl or anything like that. And the third thing is I can do complex logic inside my dependency checking utility, which is owned by the development team. So they understand what the application needs. They understand the best way to test that it's available. So why not get them to write an application and bundle it inside the container? OK, so dependency checker. So let's see what happens when are we still there? OK. I need, if it goes again, like someone hoot like an owl, and then I know. OK. So this version here, I'm in the world of .NET. I've got, inside the source code here, I've got some utilities. I've got my dependency checker. And all it is a console application. It uses a library called Poly, which is it's a policy-based utility for wrapping access to things. So all this does is it says, I create a policy that says, when I run this bit of code, I'm going to retry it 3 times. And you can have all sorts of complex policies available in Poly. It's a really good tool. But I'm not having to go back to my web application and change code. I'm doing this in a completely separate utility. So all this does is it's just going to try and connect to the database, just making a SQL connection. And it reads the connection string from the same place that the web application reads it from. So all the config I've already got set up, I don't need to worry about that. I'm just going to use the same stuff in my dependency checker. OK. And then bundling that inside the application is pretty simple. Oh, no, that's the other one. I just copy that in, and I just expand the archive. And then I've amended my startup file. So inside this application now, there is a startup file which is going to do my setting up my configuration. And it's also going to run my dependency checker. And if that fails, then the application ends, and the container won't start. And there'll be a log there saying that I couldn't start because I couldn't access the database. And then finally, it's doing my log tailing. So it's doing my logging, my configuration, and my dependency checking here. So let's deploy this. So I'm going to do a Control-R. Where is it? Number 3. Incidentally, this is I should have said this at the beginning. This is a hybrid cluster. So I'm running a couple of virtual machines on my Mac. One is Linux, one is Windows. When you're talking to a hybrid cluster like that, you just give it compose files. You don't have to say, oh yeah, please run this on the Windows node or that on the Linux node. Like you can add hints for that inside the compose file, but you're talking to the cluster as one thing, and you're saying, I've got my Java app running in Linux containers. I've got my Windows app running in Windows containers. Meh. I'm treating them all as stacks. OK. So that's done. So let's go and look at this now. So in my service list, I've got, oh yeah, I didn't show you the compose file. So I've got an extra thing in my compose file for version 3 to make use of the fact that I've actually got a dependency. So I've got, come back here. I've got version 3 of my application. I've got all the same configuration gubbins that I showed you in the Java application. And I've got another thing for my connection strings. I'm also running SQL Server in a database here, and this in a container, and this is going to be in Windows. But I could use a Linux container for this, depending on what I was doing, what I was trying to achieve. And my configuration for my connection string, which is going to contain sensitive information about how the user credentials, is coming from a secret. Now, the secret is exactly the same principle as the config. Like it comes from the cluster, it comes from the container platform, it gets surfaced inside the container at a specific location. In the case of Windows, it's always going to be in a location like this. And then in my startup script, I'm just reading that as well. So I'm taking the config from a source. It doesn't matter whether it's a Kubernetes config map, a Swarm config object, or a Swarm secret. OK, so this has been running. So let's go and check the logs here. Look at my containers. It's been up. Look at the logs. Oh, no, that's my SQL Server container. That's not good. Let's go back to the services. .NET FX. Here we go. So here are the previous containers that have been exited. Here is my new container. And here's my dependency check. So if the SQL Server database wasn't there, then I would see log entries here saying, I'm retrying, I'm retrying, I'm retrying, and then it would say, no, I'm done. And it's accepting there's going to be, there potentially is a transient issue connecting, but if it's permanently not available, then there's no point starting my application. So this is correct, so it's working correctly. If I go and update my page here, I should get a different server name. And now, when I click Execute SQL, there. It tells me the time inside the database. That's pretty cool, hey? Like I said, this is open source. If you want to run this, you can just get it and use it yourself. OK, so yeah, naughty example. But the point is now, if I'd have run that previously, I would have just got an error page. It would have just bombed out. My application shouldn't start unless it can talk to the database. And this is a nice, simple way of doing it. In the Java world, exactly the same principle. I'm using, in my startup, I've got a dependency check, pretty much the same as I've got in my Windows Docker file. I've got an environment variable to say whether I should run the check, and that's disabled by default. And that's about not breaking the developer workflow. So developers can just run it without having to pass any environment variables, and the default settings will work. Because I might be running the app, and I might not use the database for the particular feature I'm working on. So I can just spin up a container. The defaults still work. OK. Click this button. See what happens now. OK, so I've done all that stuff. So it runs before startup. It uses the config there. It has to be robust, because if this fails, if your dependency utility fails, then your application doesn't start. So you need to make sure the dependency utility itself is pretty solid. But by putting it in an actual utility rather than a script, you've got access to the whole wealth of the rest of your platform. I've done the demo. OK, health. So now my application is logging into the platform. It's reading config back out from the platform. It's checking the platform to see if the dependencies are there. In the case of Docker and Kubernetes, that's just accessing other containers or accessing external services and making sure they're available. And now I want to get health out from my application. So most of the stuff that you want to be able to do, you can do with a simple script again. But again, my preference is not to have a script to do this. If you look at a Docker health check examples on the net, they almost all use curl. So curl localhost to make sure my application is up and running. Again, there are problems with that. So my preference here is, again, to have a utility that you write in the same platform that you're running your application in. So it means you don't take an external dependency on some other tool. It means you can make it as complicated as you want. And it means it's owned by the team who are building the application. So they understand the things that your utility needs to do. If you're writing a brand new app, and you've got complete freedom, you might want to put in a diagnostics endpoint, like a REST API, inside your application, and then just have a health check that just calls that. You've got a lot more freedom if you're doing that. But if you don't want to change the code, then having a separate utility and bundling it in is a nice way to do it. This is going to run periodically. Again, that's going to be owned by the platform. So with Docker Swarm, it does whatever's configured in the Docker file. And it will run that health check periodically. And Kubernetes has exactly the same principle for health checks. The beauty of having a separate utility is that all the complex logic is in the utility. And in your application manifest, you're just calling the utility. You don't have, because you can end up with complex health check scripts that are like this, which doesn't really helpful. It's much easier to say, I've got my logic in here, and all I do is run one-line command. OK, health checking. So we're back to Java for this one. This demo is horrible, and I will explain why. I was going to cheat, but I thought, well, you can't cheat if it's open source, can you? So I'm not going to cheat. Now, let's show you how this works. I'm going to do my deployment first, actually. So my deployment is version 4. So let's do this. So I'm deploying version 4 of my Java stack, and then I'll show you what all this stuff looks like. So in my Java world, in the Swarm, my version 4, I've just got the health check configured. I'm just setting how Docker calls the health check, because the health check itself is specified in the Docker file. So the only difference in my Swarm file is to say I'm using version 4 of my application that's got the health check bundled in. I'll show you that in a second. Oh, this is the .NET one, but it's the same thing. So here, I've just got my health check in here. The difference is I'm configuring it for a particular environment. So if I'm running it in, if I'm running my container in dev and it's got a health check configured, if I'm in a single node environment, so if I'm on my laptop or a basic test environment, if the health check fails, Docker doesn't do anything. Like, it tells you the health check has failed, and an event gets emitted by the API to say the health check has failed, but it leaves the container there because it can't really do anything other than kill that container, which is a destructive action. When you're running in Swarm mode, and when you're running in Kubernetes, if the health check fails, then you've got the option for the orchestrator can take it down and bring up a replacement. So again, it's useful to be able to have all that stuff. And the version 4, the Docker file has just got a health check that calls a Java jar file. And that jar file has got all the stuff that I want to be able to do to exercise the logic of my application. Again, in this case, it's pretty simple. So I've got my source in here. I've got my health checker utility, and I'll click these various directories. Actually, I said it's pretty simple. There's a fair amount of stuff going on here to show you that actually you can do more complicated things if you write a utility than if you just use a script. So what I'm doing here is I'm setting my timeouts for the various parts of my connection. Ultimately, I'm just calling the web application inside the container and making sure it responds. But I'm setting up exactly how I expect it to work. I'm checking the status code to make sure I get a 200. I get a 200 OK response. And I'm also checking the amount of time it takes to get that response. If it's under 150 milliseconds, remember, there's no network here because I'm running inside the container. If my application takes longer than that to respond, then I'm not happy, and I want it to fail. So something's gone wrong. So you can the point is you put whatever logic you want in here. OK. Now, let's see if this works. So let's go and look at my containers. You see, yeah, this is a hateful demo. So I'll explain. I'll see if I can find out what's happening, and then I'll explain why it's so hateful. So view the logs. OK. So these are the logs for my Java application here. So I've got the same stuff in here. It checks the dependencies when it starts. It's connected to MySQL, so that's all good. The dependency's OK. The rest of it runs through. All the Tomcat stuff starts up. And then it says it started in 2.8 seconds. OK, now, this, let's see if this starts. OK, this slow mode here, there's some code in the web application. So randomly, like 4 out of 10 times, it takes longer than 150 milliseconds to respond. So the point being that it should fail the health check periodically. And if I wait here long enough, then when Docker makes the health check, it'll hit the slow mode, it will fail the health check, and it will replace the container. And when I refresh this, I'll get a different server ID. But because it's non-deterministic, then we could be here forever. So I'm not going to show you that. You have to take me on trust on that. But like I said, you can run this yourself. It's cool. OK. So that's the health check part. And again, exactly the same principles in the .NET world. So in the .NET world, I've got my health check specified just calling an exe, just calling a .NET executable. And that .NET executable looks very similar to the one that I built for in Java. So the program file just makes a call to localhost. Again, it checks the elapsed milliseconds, and if it's taking too long to respond, it will return an exit code of non-zero, which means that Docker then knows that it's not healthy. So again, fairly simple, but it means it's really powerful. OK, back to here. Click this button. OK, so because this runs periodically, and because you're now allowing your platform to manage your old application in the same way that it's looking after your new applications for you. So if something goes wrong in your old app, and you choose how to define what wrong means, but then the application can do interesting things. It can restart your container, or it can replace it with a new one. And this is also really important for rolling updates. Like, all the orchestrators have a rolling update policy where I'm going from version 1 to version 2. It will replace the containers 1 at a time, or 2 at a time, or whatever you configure. It checks the health of the new container before it sends any traffic in. And if there's a problem with the new version, it can automatically roll back for you. To get all that stuff for free with your 10-year-old application, you just need to make sure that it's producing a health check. OK, and the last one is metrics. So what you tend to find, we've talked about our Docker journey a lot over DockerCon. One of the things that where people hit a barrier and they get slightly concerned is they've taken their application, they've made it run in containers, they've tried it in all the different environments, it's all good, they're ready to go to production, but they don't know what's going to happen when they go to production. They don't know how to check everything's OK when they've got 100 containers running their application. And this is where the metric stuff comes in. So most of the platforms already have metrics that they're collecting for you. Again, similar to the logs, your application is probably writing logs already. In the case of Windows, .NET and IIS write to Windows performance counters. That's already happening inside the container. In the case of Tomcat and Java, there's JMX stuff potentially happening. There's all sorts of things being captured already. And all you want to do is you want a utility to export those metrics that are being given you for free and make them available to the container platform. So that will enable you to do things like have Prometheus running, which is scraping metrics from all your containers, and the metrics that it's scraping for your traditional applications are your Windows performance counters or your Java JMX counters. OK, this is the last demo, so let's show you how this works. And I'm back to .NET for this one. So what I'm doing here, I'm using a utility that already exists. So I've already got a sample application which has got one of these exporters written in it. So I'm using a multi-stage Docker file here for a slightly different reason than you commonly find. Commonly with a multi-stage Docker file, I compile my app in stage 1, I package it in stage 2. You can also bring in dependencies, common dependencies using the same idea. So I've got a Docker image that's got this application that I want to use in it. So I've got a from line in there that says here's where my exporter comes from, and then I copy stuff out from the exporter into the place where I expect it to be. And all this little utility does is it just scrapes those Windows performance counters. And I've got this starting in the background. So it's going to run this metrics exporter in the background. It's going to provide a new entry point in my application. So a specific port is providing metrics in Prometheus format. That's what my utility does for me. OK, so let's go and do this deployment. So final one. OK, and then in the compose file for this, there isn't anything special at all. So all the stuff that I need to do for this is baked into my Docker file. So all I'm actually doing is there's a new port being exposed by the application, but it's not being publicly available. So there's a random port 50505 where the metrics are living, but they're not publicly available. They're only available within the Docker network. Further on in this compose file, I'm adding Prometheus. So I'm running a Prometheus server 2 inside a container. That I am publishing the ports for that just for the sake of this demo. This is running on Linux. So I've got a Linux container running Prometheus, and the metrics are coming from my Windows container. That's fine. They're all in the same Docker network. They're in the same overlay network. They can talk to each other with DNS in the same way as if they were both running on the same host. OK, so let's see what's happening here. I've got check my services. So these are all being deployed as stacks. So I've got 2 stacks here, Java and .NET. The services in my .NET, I've got Prometheus now. I've got my web application, my SQL Server. So if I go back to here, and if I just refresh a few times to get some stuff happening, the application is the same, the UX is the same, all the other great features that I've bundled in are still there. But now I can browse to Prometheus. And Prometheus is scraping all this stuff. And this has all come from the fact that these are already performance counters. These are already Windows performance counters. So you'll recognize some of these if you're used to working in the ops in the Windows world. There's a request per second in there. And I can execute that, switch to a graph, take down the time span. And you'll see my request per second coming in there. I've done nothing to my application to make that happen. I'm getting all these metrics for free. And the little utility that I've written is, again, it's pretty simple. And you can configure the performance counters that it reads out. The Java thing is exactly the same concept. So in Java, I've got my version 5 Docker file. There's a whole bunch of stuff that where's my version 5 Docker file? There we go. There's a whole bunch of stuff that I drag in from an exporter that someone's written for Tomcat already. So I've got a Tomcat exporter from Prometheus. I'm bringing that into my application. Again, multi-stage Docker file. And then all that stuff's just available in exactly the same way. So I can deploy my Java application and get the same metrics out, the stuff that's being already captured by Tomcat. OK. Good stuff. So now my old applications fill out all the holes in the container and integrate with the platform in exactly the same way as a new application. So all the benefits of a cloud-native app of being able to be dynamically managed and container packaged and being able to run them without having to care about where they run are available now to your old applications. Don't change code. You don't need to do anything complicated to your application. You just bundle some utilities with it, and the complex stuff happens in a Docker file. And most of these Docker files are still only 20 or 30 lines, so it's not complicated. And I've been showing you this on a hybrid Swarm and Enterprise Edition. I've been running on Swarm mode, but of course we've also got Kubernetes. And the beauty of this is I can take my old applications and my new applications, I run them all in the same cluster. And that cluster can have my monoliths, and they might not be monoliths, they might be new applications written in older frameworks, alongside my cloud-native apps and my serverless apps, all in the same cluster. I deploy them all in the same way, I manage them all in the same way, I monitor them all in the same way. OK. How am I doing? Oh, over. But then there was that screen issue. So like, you can't blame me for going over because the screen went bad. OK, next steps. This is the one to take a photo of. Right at the end there, that's the GitHub link for all the demos. Please don't email me about my Java code. I am a .NET programmer. If you're interested in some more depth here, we've got some videos up on YouTube, a series for .NET and for Java, showing you how to do this stuff in a little bit more detail. And obviously, if you want to run Docker EE, then that's the trial. Thank you very much for coming. I hope that was really useful. Do remember to vote, and I'll see you around. Any questions, just come and find me afterwards.